The human visual system is incredibly complex. We believe it has over 60 billion neurons. As a child, we learn to understand what we see through hours and hours of experiences. For example, you might see a toy car and you look around it and you're shown that that's a toy car. But teaching computers to see is a lot harder. We have to do this through supervised learning. What we do is we show it these images of these say toy cars, and we label every pixel as to what it is. But we only have a very small amount of data, much less than a child has when they're growing up, and we use that to teach a machine to see. Some of the big car manufacturers are using technologies like laser, radar, cameras as well, and combining all these to try and create an autonomous vehicle. What we're trying to do here is achieve all this with just vision. Humans can drive using vision alone, and so we're hoping to teach a machine to see to be able to do the same thing. So there are three main technologies behind autonomous cars. The first one is where am I, the second one is what's around me, and the third one is what am I going to do next. In this work, we address the first two with our relocalization system and our semantic segmentation system, SegNet. SegNet is a system which can label each pixel of an image with what it sees. So for example, it can take a road scene and label, here's a car, here's a pedestrian, here's a road. We can do all this in real time. In the short term, this could potentially be incorporated for drivers to warn them of any hazards they might encounter on the road. We've taught our system to do this using supervised learning. We've taken a bunch of images and hand labelled them pixel by pixel with what's in the image, including cars, pedestrians, cyclists, and everything you'd find in a road scene. We've then taken the system and shown it these examples to teach it to reproduce this. Once it's learnt to do this, what we can do is we can show it images it hasn't seen and try and get it to reproduce the results. Initially, we had a small network which we trained with some images from around Cambridge. It was able to work around Cambridge, but it didn't work with images from around other parts of the world. We've expanded this network from 500,000 parameters to 10 million parameters, and from about 300 training images to 5,000 training images. And this has allowed us to have excellent performance from places all around the globe. Our relocalization system can work out where you are and let you navigate from a single colour image. What it can do is it can take a photo from your smartphone and put you on a map. This is really important because it lets you do this in places where you don't have GPS, such as if you're indoors, or places where GPS signal isn't readily available. It also gives you the orientation. These sorts of things are really crucial if trying to build an autonomous car. We've demonstrated that it works on a kilometre-long street. You can just take a single photo and it'll determine where you are to a couple of metres, couple of degrees. We taught our navigation system to learn to localise using a technique called structure motion. This technique takes a video and uses computer vision to determine the geometry of the scene. Once we have this geometry, we can then teach our system to learn to navigate based on this data. Both of these systems are going to be required in an autonomous vehicle, and they run on the same sort of architecture, but they do solve the two separate problems of where you are and what's around you. Work in the field of artificial intelligence and deep learning has absolutely taken off in the last couple of years. It's achieved amazing performance, but what's cool about our group is that we've made a system which, using deep learning for the first time, can work out where you are and what's around you for autonomous robotics. This technology is still in its early stages, and in the short term we're probably more likely to see it on a domestic robot, maybe something like a robotic vacuum cleaner. There's still a lot of work to be done for the public to trust these sorts of sensors before we might see it on the road driving your own car.